When you're boiling water on the stove, let's say, to make coffee, and you accidentally forget it on the heat, you'll notice that the time it takes for all the water to evaporate is much longer than the time it takes to boil it. Phew! When you're heating water, the heat from the stove is used to raise its temperature, and the heat used to raise each gram of water by 1 degree is called specific heat. When the water reaches 100 degrees, its temperature stops rising, and it starts using the heat it receives to change phase, that is, to go from liquid to vapor. This is called latent heat, which is 540 times greater than specific heat. Specific heat only raises 1 gram of water by just 1 degree Celsius. However, even considering half a liter of water boiling on the stove from 23 degrees Celsius, room temperature, to 100 degrees Celsius, the energy needed to evaporate the water is 7 times greater than to boil it. That's why evaporation takes longer than heating. Besides water's specific heat being very high, its latent heat is also very high, much higher than its specific heat. And this, combined with the phenomenon of evaporation, which is natural and only needs ventilation, gives us a cool trick to refresh ourselves without having to spend on electricity or air conditioning. The human body and plants use latent heat to cool down. Your body's sweat needs energy to evaporate, and it steals energy from you to do this. Have you ever noticed that environments with plants are cooler? Actor Michael Berryman, who has a skin condition that prevents him from sweating, needs extra care when filming in the desert or very hot places. Clay water filters and a dog's nose are cool because of evaporation. Green roofs, like on the New York Museum, or vertical gardens, cool the environment through plant transpiration. A wet wall, combined with ventilation, can create a natural air conditioner or an Indian air conditioner. The biggest source of energy for storms and hurricanes is the heat released by water vapor condensing in the clouds. Fog, at dawn, reflects some of the sunlight, and as it evaporates, it steals heat from the air. The bottom of a waterfall is cold because free-falling water has a lot of surface contact with the air and a lot of ventilation, which causes a lot of evaporation. But be careful, because water's latent heat is so high, steam burns are much worse than burns from boiling liquid water. That's it. It's science, and it's free.